one you do is the dissolved oxygen test. This is one that has to be done in the stream, and a sample cannot be taken back into the classroom to do. This is one that has to be done here. In order to get a good oxygen reading though, we have to know the temperature of the water. And that's the first thing we always do when we're doing dissolved oxygen. So we're going to lower our thermometer in the water. And again, in that main stream flow. And then we're going to let that calibrate for just a moment to make sure we get a good temperature. Did you know that there's a lot of oxygen in the water? Well, there is. And everything that lives in the water has to have that oxygen to survive. That's one of the reasons that doing the dissolved oxygen test is so important. Oxygen can get in the water several ways. One, if there are plants here in the water, when they photosynthesize or make food, that process releases oxygen into the water. Water can also have oxygen coming in from riffles. If there are big rocks or maybe branches in the water that create some surface breaking of the water, it can pull oxygen into the water too. And big storms can bring oxygen into the water. So after a rain, sometimes we'll see oxygen levels go up just because that surface of the water is broken and oxygen from the air is being pulled in. Lots of living things need that oxygen in the water. We also need that temperature of the water because different temperatures of water can hold different amounts of oxygen. The cooler the water is, the more oxygen it can hold. As water heats up, it cannot hang on to oxygen. That's why when we're in a stream, we love to see lots of shade. It helps keep the water cool and helps keep those oxygen levels up. So we're going to start the dissolved oxygen test. This is the sample cup from our kit. You'll notice that it's got several measuring marks on it. We're going to get 25 milliliters for our test, which is the top mark. Again, we're going to triple rinse the cup and then get our sample. When you're getting the sample for oxygen, you always go under the water, not from the surface. If we pull it from the surface, we're going to mix oxygen from the air in it, and it won't give us a good reading. So we'll go underwater with our cup, rinse it 3 times, again using good science techniques. And then get our final sample. It's good to hold the cup so that the water is flowing into the cup, and pull it up. Now I've got a little more than the 25 mil, so I'm going to pour a little bit out. So now we're at our 25 mil mark. So we have our 25 milliliter sample. For this test, we're going to use this glass ampule. This is part of our chemistry test for dissolved oxygen. You put your ampule all the way to the bottom of the sample cup and then tilt it straight up with a little pressure, and you should hear a snap. That means the tip has been broken on that ampule, and through capillary action, our sample has been pulled into the ampule. So now we're going to invert this 5 times. Each time you have to make sure the bubble goes all the way to the top. That's 2, 3, 4, 5. This helps mix our solution so we know that our sample is being prepped correctly. Now we wait for just a couple of minutes to let that color set. For the dissolved oxygen test, it's recommended to wait 2 minutes. we'll pull out this rack of colored tubes that's in the kit. What we want to do is compare our sample to the colors in the rack. So you place it right in the rack so that the background is the same between your sample and the ones we're comparing it to. So for today, as I move this around, see if you think you can decide what color. When you're reading this, it's good to hold the rack fairly horizontally and not be in shadow. Never wear sunglasses when you're reading these color tests. So I think for today, we're going to call this a 6. So the number is here at the bottom. That means we have 6 parts per million of oxygen in our water sample. So that's important to know. So on our data sheet, we can record the number 6 in our milligrams per liter. So in fresh water, parts per million and milligrams per liter are the same thing. So I'm going to put a 6 in here. So we know what that was. Now we have to figure out saturation. The reason that we have to figure out percent saturation with oxygen is because water at different temperatures has the ability to hold different amounts of oxygen. So we have to do something that helps us compare the temperature of the water with how much oxygen is in it. And percent saturation is the way we do that. So we're going to use this chart next. So on this chart, you'll notice there are a lot of numbers. Across the top line, that is our water temperature. Now for today, we said it was 25 degrees. So we'll find 25 right about here on the chart. Then our milligrams per liter is on this bottom line. And we decided for today it was going to be a 6, which is here on the chart. When we know those two numbers are 25 and our 6 milliliters, we're just going to connect the dots. Here's our 6, here's our 25. Where that intersects this diagonal line, that will give us our percent saturation. So for today, our percent saturation is about 70%. So that's pretty good. So what do you think? Do we want a high reading or a low reading for dissolved oxygen percentage? If you said high, that's correct. The things living in the water like lots of oxygen there. So a higher reading is always a sign of better health in the stream. So now we look at our data sheet one more time, and here's our dissolved oxygen setting, and we're going to put our 70% saturation in this square. So we've completed the dissolved oxygen test. For today, it's at 70% saturation. We want to make sure that we do a nice cleanup too. So again, we pull our waste bottle. We pour any leftover sample water directly into the waste bottle because it has that glass tip in it. We don't want to pour it back in the stream. So that goes in there. The ampule that we use can go right in there as well. And we're done.
Learned a lot about dissolved oxygen. So now it's time for some reflection questions. Let's take a few minutes to think about what this actually means. So look at the data featured here, 25 degrees Celsius, 6 milligrams per liter, and 70% saturation. What does this tell us? What do you notice? Is this good? Is it healthy? Take a few minutes to reflect on what this actually means.